Today we're going to learn about weight and mass. And what I want to start with is telling you about mass. Mass is a measure of matter. That means how much stuff you are made out of. And your mass is measured in kilograms. So my mass is 65 kilograms. And the way that I would write that down would be to say M is equal to 65 kilograms. What are kilograms? It's really measuring a physical property of your body, how much stuff you are made of. You could actually see when somebody changes their mass. You would gain mass by eating. Or maybe putting on a heavy backpack, I suppose you could say. If you want to lose mass, a visual gross way would be to say that you could throw up or you could lose a limb, but we're talking about changing what you are made out of. So sometimes I say you have to eat or puke in order to change your mass. And so really, you know, there's other ways of putting more things into your body or taking things out of your body. But mass is how much stuff you have, and it doesn't depend on what location you're at. You could go to any location in the universe and my mass would remain 65 kilograms as long as I didn't eat a bunch of food on the way there or throw up on the way there. Okay, so the next thing I want to talk about is, isn't weight just that same thing? And the answer is no. Weight is different. Weight is actually a force. A force is something that's either like a push or a pull. And weight is really a pull. And so it's measured in newtons, and it's the force that gravity pulls you down to your planet with. So you need to be near a planet here, and that planet is actually pulling you down with a force. And the harder that planet pulls you down, the bigger force of gravity you have, the more weight you have. It's caused by an attraction between two objects with mass. So you have mass, the Earth has mass, you're attracted to each other. You have mass, the moon has mass, you're also attracted to each other. But it turns out that you're more attracted to things that have more mass. So if we went to the moon here, you wouldn't be quite as attracted to the moon. Even though you look the same, it's a smaller planet, so it's going to pull you down with less force. When we talk about your weight, we really mean the force of gravity between you and the Earth, how much the Earth is pulling you down towards its surface. And so your weight changes based on your location in the universe. You can still have all of that mass that makes you up, but if you're not near a planet, you could have no weight. You could be weightless. Even though you still have all of your stuff, there's nothing to pull on you and give you that force that is actually called your weight. So we call weight your force of gravity. And a quick little check question would be this: where would you have more mass? If you go to Jupiter or if you go to the moon? Where would you have more mass? The answer is your mass does not depend on what location you're on. You have the same. Your mass on the moon would be the same as your mass on Jupiter because you didn't eat or get sick as you were going from planet to planet. But Jupiter would pull you down harder. On Jupiter, you would weigh more. On Jupiter, you would have a bigger force of gravity. So we would say that you weigh more on Jupiter. You still have 65 kilograms of mass, but you would have more newtons of force. So your weight depends on your location in the universe. And the bigger the planet, the more massive it is, the harder it would pull you down. If you were on Jupiter, it'd be really hard to even stand up. It would pull you down so hard, your muscles wouldn't even be strong enough to allow you to stand back up. Whereas if you go to the moon's barely pulling on you. You would be able to leap tall buildings in a single bound, just like Superman. That's the whole premise of Superman, is he trains on Jupiter, gets really strong muscles, and when he comes to Earth, all of a sudden everything's easy for him because he's not being pulled down as hard. His mass doesn't change, but he's not pulled down as much, so his weight is different. So we're going to represent your weight as your force of gravity. Whenever we ask you about your force of gravity, that's the same thing as asking for your weight, and that is not the same thing as your mass. So these two are synonyms to each other, and they're both measured in newtons, whereas your mass is measured in kilograms, and it doesn't depend on your location in the universe. When you go to different planets, your weight changes, and it's kind of fun to see all the different places that you could go and what that would do to your weight. And so I have this little link here where you can enter your weight on Earth here. Let's say that I weigh 150 pounds. When I go to the moon, I only weigh 25 pounds. But when I go to Jupiter, I weigh 379 pounds. I don't look any different on the moon than I do on Jupiter. I still have 65 kilograms of mass no matter where I go. But how hard the moon pulls me down is less, and how hard Jupiter pulls me down is more. Feel free to play with this link as you are exploring these slides. The next video you'll get to see is all about more forces, but for now I'm going to say goodbye for your mass and weight video recording.